Pythagorean identities turn messy trig expressions into algebra you already know. On the SAT, they are your fastest simplification tool. We will start with sine squared plus cosine squared equals 1, then stretch into tangent and cotangent forms and finish with a harder simplification. We will also call out a notation trap. sin² is not the same as sin of theta squared. Identities are not extra facts to memorize in isolation. They are shortcuts that come from the Pythagorean theorem and the unit circle definitions. When an expression looks complicated, ask whether sin² plus cos² can collapse part of it to 1. The fundamental identity is sin² plus cos² equals 1. On the unit circle, x is cosine and y is sine, and x² plus y² equals 1. That's where the identity comes from. Divide the core identity by cosine squared, and you get 1 plus tangent squared equals secant squared. Divide by sine squared instead, and you get 1 plus cotangent squared equals coscan squared. For most SAT problems, sin² plus cosine squared equals 1 does 90% of the work. Easy example. If sin theta equals 3/5, find cosine theta up to sine. Square both sides conceptually. Sine squared is 9/25. So cosine squared is 1 minus 9/25, which is 16/25. Take square roots. Cosine theta is plus or minus 4/5, and you pick the sign using the quadrant. Medium example. Simplify 1 minus cosine squared theta, all divided by sine theta, assuming sine theta is not 0. Replace 1 minus cosine squared with sine squared, then sine squared over sine is sine theta. This is a classic SAT pattern. Factor identities into sines and cosines, then cancel carefully. Always watch domain issues. If cosine theta is 0, tangent expressions blow up, so identities involving tangent have holes you must respect. On the SAT, most items stay in safe ranges, but knowing where an expression is invalid protects you from trap answers. Harder style, show that tangent squared theta plus 1 equals secant squared theta, starting from sine squared plus cosine squared equals 1. Divide every term of sine squared plus cosine squared equals 1 by cosine squared theta. Simplify to tangent squared plus 1 equals secant squared, and that is the structure behind many algebra manipulations. Common mistake, confusing sine squared theta with sine of theta squared. Different meanings, different numbers. SAT tip. Most SAT trig cleanup uses sine squared plus cosine squared equals 1. Reach for it before you hunt for angles. If you see a squared sine or cosine inside a bigger expression, ask whether the rest of the pieces can become a second square so you can factor like a difference of squares. When an equation mixes sine and cosine linearly, sometimes squaring both sides helps, but extraneous solutions appear, so you must verify in the original equation. Identities are your cleanup crew. Use them to shrink expressions before you reach for heavier tools. If you must simplify a fraction with sine and cosine, factor first. Cancel common terms and never cancel across a plus sign without factoring. NovaMaths practice banks repeat these patterns until the identity feels like the obvious first move, not a desperate last resort. When you see secant or cosecant, rewrite them as 1 over cosine or 1 over sine, then apply the same Pythagorean cleanup on the inside expressions. That habit keeps every path feeding back into sine squared plus cosine squared equals 1. Recap. Sin squared theta plus cosine squared theta equals 1. You can derive tangent and cotangent formed by dividing the core identity by cosine squared or sine squared. Watch exponent placement and use the identity before you chase unnecessary angle calculations. Practice more on NovaMaths.